Hello, dear all, and welcome back to another online session of MD Microdetectors. It's Giovanni Principe speaking, and I'm honored to introduce you in this second Tech Innova session. Today, we want to show you some new products that we developed during the last month. In particular, we want to show you these new amplifiers for optical fibres, both with pigtail connection and with cable. And together with this new amplifier, the new plastic optical fiber. So basically, today we are going to talk a little bit about the main technical features of these new products. Then we want to show you, as usual, during the practical part of our online session, the way of adjusting these new products. And then we want to share the main and the most interesting and, let me say, challenging practical applications. So a lot of interesting stuff to say and to see. I'm not alone here because there are two colleagues of mine, in particular Giovanni Di Lorenzo, who is, let's say, directing from a technical point of view this online session, and Fabrizio Marchi, who is in charge for the question and answer profile. So if you have some doubts, if you have some questions, if something is not so clear, please do not hesitate to write your questions and address them to Q&A Fabrizio Marchi. And Fabrizio will be very happy to support you to answer to your question. So I think that now we are ready to start. But first, please enjoy this brief introductory video. I hope you enjoyed this brief video, which basically was just a demo about the contents that we are going to talk about and that we are going to show you during this session. In particular, you have seen something about the adjustment of new products and something about, let's say, some particular practical applications. But now let's go more in detail about the content of this online session. Okay, so basically we are going to talk about, first of all, the main technical features of new FY2, FY3 amplifiers for optical fibers. Then, obviously, we are going to talk about new optical fibers belonging to the CF series, in particular with different models, coaxial, 90 degrees emission, and area fibers. Then, during the practical part, we want to show you how to adjust these products. And some challenging applications, in particular the detection of water drops falling and the detection of transparent objects. First of all, let's say, introduce the main aspects of this new product, of these new amplifiers. We are talking about basically of a product with a very compact size, product based on DIN rail and based on red emission. Then you have a double display in order to see, in order to visualize both the settings that you have adjusted and the observed values. The adjustment, as we are going to see during the practical part, is performed through the teaching button. The housing is plastic-based, in particular is made up of polycarbonate. Then we are going to discover that with these products it is possible to work in 4 different modes: high speed, fine, super, mega. It depends on the desired switching frequency. It depends on the speed you need in your applications. It is possible to set a delay function. And just for the FY3 models, it is possible to set the anti-mutual interference function. What does it mean? It means that you can work with this function with more than one, and in particular with a maximum of 4 optical amplifier for optical fibers, working, let's say, side by side, working together. As I said to you before, when I've shown you this product, we have both cable and pigtail products. Okay, let's talk about now the codification, the item codification. Basically, we have the first part showing you the series. So we have a distinction between FY2 for advanced models and FY3 for the super advanced models. Then 0 means that you can select in your output the light on or dark on, let's say, mode. And then for what concerns the logic, the output logic, you can have P or N on the basis of the fact you want to use a PNP or NPN product. 0 means that you are using a plastic-based product, while the last letter is related to the electrical connections. Basically, we have a cable connection, and it is related to the A, and pigtail connection when you have V. Okay, here in this picture, you can observe the keypad. And in particular, I want to underline again the presence of the double display, which is very useful for observing the settings and the, let's say, the values that you are observing in your application. Then you have more buttons. In particular, with the set button, it is possible to adjust the amplifier in different ways: fine, standard, dynamic. And it's something we are going to show you during the practical part. Then with the, let's say, with the button mode, it is possible to change the status. It is possible to skip from the light on to the dark on mode. And it is possible also to set different working modes that you can observe in these 2 tables. As I said to you before, there are 4 different working modes on the basis of the switching frequency you need. Starting from the high speed, then for fine, super, mega, you are, let's say, each time you are reducing your switching frequency. So you are going from the 12.5 kilohertz for the high-speed model to the 32 hertz of mega models. Of course, if you increase the switching frequency, as you can observe in this graph below, in the red straight line, at the same time, you are decreasing other kind of performances, in particular the distance and the response time. So in case of high-speed models, you can use them if you really need a very fast product. So if the switching frequency is the performance you want to maximize. Of course, in this case, you are reducing the distance because you are reducing the emission power. And we are going to underline also this aspect during some, let's say, some videos in the practical part. Okay, so what about the special functions that we are introducing with these new models? First of all, the anti-mutual interference, as I said you before, just for the FY3 models, so just for the super advanced model. The possibility of setting the delay function, in particular, delay on, delay off, one-shot delay, and then the detection of objects with shiny background. Okay, so it's a product allowing you to face challenging applications. Here in this table, just a brief, let's say, description of all the combinations of new models. In particular, both FY2 and FY3 are based on teaching button as adjusting procedure. The FY3 present the no mutual interference function. And for both of the series, there is the possibility of having cable or pigtail models. And there is the possibility of setting the light on or dark on, let's say, output with the PNP or NPN output logic, so different models. Here, just to underline the compactness of this product, as you can observe, the length, let's say the major size is, let's say, something more of 7 centimeters, so very, very small product. So the, let's say, the analytic question is FY2 or FY3? It depends. It depends on what? It depends on your applications. It depends on the necessities that you want to satisfy in your applications. Because on the one side, we have the FY2 models with high switching frequency, in particular in the mode of high speed. In fact, I've shown you that we can reach the 12.5 kilohertz in terms of switching frequency. On the other side, if you want to maximize other kind of performances, for instance, you want more precision, you want more power, you want the anti-mutual interference, you have to select the FY3 models. Now, just a picture when we want to compare all the amplifiers for optical fibers, let's say putting together the new models and the models that we already had in our catalog. We want to just to underline the fact that thanks to these new models, we are completing our product range in terms of amplifiers, because we are offering some new functionalities that we had not in our catalog with the existing amplifiers. Just one thing I want to underline is the fact that with this kind of new amplifier, it is not possible to put together glass fibers. So if you want to use glass fibers, you you should select other kind of amplifiers. In fact, as I showed you initially, we are launching today also new optical fibers going together with these new amplifiers, but they are plastic based, so no glass. Okay, now once we have described, let's say theoretically, the amplifiers, we are entering the practical part of the amplifiers. In particular, now we want to show you something about the teaching procedures in different conditions. First of all, switching point adjustment, then the adjustment in full saturation condition, and we are going to explain how does it mean saturation condition. The factory reset, which is we think is one of the most important functionalities you should know when you buy a new product. The light on, dark on output setting, and the dynamic adjustment. So now please pay attention, because it's a very interesting part, and I'm leaving now the speech to my colleague Giovanni Di Lorenzo, who is going to, let's say, to showing you practically basically how to play with these new amplifiers. So please, Giovanni, you can go on.
Thank you, Giovanni. I'd like to share with you some video now where you can see how it is easy to adjust the sensitivity of FY sensor. So just a second that we start with the video. Okay. Now we see the first mode to teach FY sensor, two-point sensitivity adjustment. The first point on the target, the second point on the background. It is the most common way to teach the sensor, and we will see that it is also very easy. So when we have the target in the right position, we have only to press the set button to fix the switching point, so on the target. Then we can move the target, and again we press the set button to fix the background. As you can see, just a little movement from the target switching point to the off point, we can see that the output is switching. This is the most common way to teach the most common condition. Sometimes we can have a very different condition. For example, if the target is very close to the sensor head, or in case of very shiny object. In this case, you can see that the energy received is very, very high. So it's almost impossible to teach in the correct way the sensor. So even if we try to teach the sensor as we perform in the previous way, we see that the sensor is not able to teach correctly. So as you can see, we have an error. So how to work in this way? You have to reduce the energy emitted by the power. How? We have to press set and mode button at the same time. So as you can see, now the emission is decreased, and now we don't have a saturation condition, so we can teach, as in the previous way, the position of the target and of the background, and we can work very, very easily also in this way. So this is very common if we need a very high precision with the target very close to the sensor head, or with the target that is very, very shiny. So in this case, we have a different of few millimeters from the switching point and the target position. One of them, as Giovanni said before, one of the most important commands that we have to know very well is the factory reset function. On this sensor, we have a lot of commands. So if you have to operate and restore the factory condition, could be very important to start again to work in the correct way. How we can perform this operation? We have to press set and preset button at the same time. We enter in reset mode. With the mode button, we accept this program. We select by the keypad the init condition, so initial condition, mode to select, OK, and we have now restore the initial factory reset conditions. Another thing that is very easy and also common to perform is the light on, dark on selection. So also in this case, it is very, very easy. You have just to press the mode button, and by the keypad, we have to select light on or dark on. Very, very easy. So as you can see, now we are working on light on. So the target is detected when, and the output is activated when the target is close to the sensor. But we can also switch from light on to dark on. And now the output condition is the opposite of the previous condition. So the target is in off state when it is close to the target, is on state when it is far from the target. As you can see, very easy to switch from one output condition to another output, to the other output condition. I just like to show better how to perform the factory reset. So I have highlighted the video of the sensor. So just press set and preset at the same time. You enter in the reset condition, reset program, mode to accept, enter by the keypad in the init mode again to accept, we can give OK, and very easy to restore the factory reset. In the previous videos, we have seen that a condition that where we have the target that is fixed. So it's very easy to put the target in the right position, remove the target, and have the background. What happens if our target is continuously moving? So we don't have a possibility to stop the movement. As we can see that we have, in this case, the target that is moving. So also in this case, it is very easy to set the sensitivity of the sensor. Just press the set button. We wait some seconds to acquire the working cycle, and then again press set again. So the sensor now is set in the right condition to work in the correct way, also in this case. So I pass again the speech to Giovanni to continue the presentation. Thank you very much for your attention.
Okay, thank you, Giovanni, for this clear explanation of how adjusting the new amplifiers. As you have seen, it is not so difficult. It is not an impossible task to, let's say, to perform, but the contrary is something also, let's say, also a child can perform. So you can have fun in adjusting these new products. So now we are going to go on, but first we want to summarize some main, let's say, main aspects that we have seen about the new amplifiers. We have seen that the adjustment is performed through the teaching button, as you have seen in the videos. We have both models with cable and models with pigtail in terms of electrical connection. The emission is red-based. You have the double display, the anti-mutual interference, so the possibility of working with till 4 different amplifiers side by side in case of FY3 model, the delay function, and the 4 modes for different response time or switching frequency on the basis of the necessities that you have in your applicative context. Now, let's talk about the new optical fibres. Let's say the complementary product with respect to the amplifiers. And let's start a little bit about the codification, the item codification. Also in this case, we have the top part of the code, which, let's say, shows you the series. In particular, CF means plastic fiber. Then you have this letter here, which could be DCTA on the basis of different models. So different, let's say, ways of working, diffuse, coaxial, through beam, so 2 elements, emitters plus receiver area. Then this other letter, which could be A or R, on the basis of the positioning of the emission head, so on the basis of the fact it is an axial or radial, so 90 degrees emission head. This other letter states, let's say, the mechanical features of the head. So you can have smoothed, treated area head. Then you have, let's say, dimensional information. First of all, the head fiber dimension, the fiber length, and the fiber core diameter, which is the last part of the code. Now, we want just to show you some variants, like in this case, where we have the this fiber coaxial with axial emission, M4 head, and let's say 2 meters long cable. Here we want to underline the presence of this, let's say, plastic part here, which allows you to bend the product, to bend the fiber without breaking it. And now Giovanni is showing you, so please pay attention. He is bending the fiber, but without breaking it. It is something possible with this kind of plastic or fiber. So it's a, let's say, it's a plus in terms of mechanical flexibility. This is another kind of model where we have the 90 degrees emission, so radial with respect to the cable axis. Here you have axial emission, but with a bigger head, in this case M6 head. M6 head with 90 degrees emission. In this case, we have the through beam fiber, so 2 elements, emitter plus receiver. And now, let's say this is very, very small, because we have the head with a diameter of 2 millimeters. The particular, let's say, feature of this fiber is the width of the angle, the width of the spot, which allows you to detect also some challenging materials. And we are going to see it during the last part, during the part devoted to the challenging applications. Here we have the area fiber. So also in this case, we have the emitter plus receiver with axial emission, but we have also the area fiber with the 90 degrees emission. It depends on your, let's say, installation requirements, installation physical condition. So now, as we did before for the amplifiers, it's time to show you practically how to work with the fibers. It's the reason why I'm leaving again the speech to my colleague Giovanni, who is going to show you how to play with the fibers.
Thank you, Giovanni. Now we are looking how to insert in the correct way areas fiber in the amplifier. This is a thing that we have to take care because we want to obtain a very good performance on the sensor. So now we see how to, with the small area sensor. So if we install the sensor, the fiber inside the sensor up to the end of the fiber, we see that the emission could be very irregular. This is not the correct way to work. We have to take care of this condition because the sensor is not able to detect the target in the correct way. How we have to overtake this situation? It's very easy. We have just to extract just a few, the fiber from the sensor, few millimeters or less, and we see that the emission now became irregular. So in this case, we have a regular emission, so we can work with this fiber at the maximum, its maximum performances. So we can see that now we can work in the correct way. The same for the other area fiber, the H6 fiber. So also in this case, we see that if we insert till the end the fiber inside the amplifier, we have that the emission is very irregular. Also in this case, the performances of the sensor are not correct. So as we see before, we have to extract just a little the fiber from the amplifier to adjust the luminosity of the fiber, the emission, and so in this case we can work in the correct way. I want just to underline that this condition have to be performed also for the coaxial fiber. So also with the coaxial fiber, we have to take care that this is regular. So I pass again the speech to Giovanni to go on with the presentation. Thank you for the moment.
Okay, thank you, Giovanni, for again for your clear explanation about the way you should use the optical fibers. Now we are moving towards the applicative context. Of course, a lot of different applications are possible with these models, but we have selected two of them. Let's say among the most challenging we thought about. In particular, we realized, let's say, an applicative demo with the detection of water drops falling down with a FY3 amplifier and an area fiber. Then we realized another challenging applicative context with the detection of semi-transparent materials. In this case, also with the reflector, so over a system made up of amplifier and diffuse fiber, we have also the reflector. So now I pass again the speech to Giovanni, who is going to show you this final technical part.
Thank you. And now we will see two particular applications that we can solve with this type of fibers. The first is detection of drops, oil, waters, and so on. The first thing to do is, since we work in a very close way, to decrease the energy emission from the sensor. So as if you remind, if you select high speed, you decrease the energy. So in this case, we have to select high speed working mode to select the minimum emission energy. So we have to press mode, enter in the program mode, and so we can select by the keypad high speed. As you can see, the energy level is decreased. Then we also introduce another point, that is the delay on the delay off. Since the drops are very, very small, the signal could be very, very fast. And so your device, PLC or a relay, could not be able to detect this fast signal. So we introduce a delay off on the output. So in this case, we select a delay off of 0.5 milliseconds. So with the keypad, we increase the value up to 500, 0.5 milliseconds, 0.5 seconds. Then we accept this value, finish the program function. As before, we select the sensitivity of the sensor by the set button. So we press set to select the sensitivity. At this point, with the keypad, we decrease the sensitivity of 10 points to be able to detect very, very small energy difference between standard condition and when the drops is passing. So by the keypad, we decrease the sensitivity. 10 points is, I think, in this condition could be correct value. And now we can start to work with the drops. In this case, we have drops of water that are very challenging because they are very transparent. It's easier to detect drops of oils, for example. But as you can see, when the drops is passing, the output is activated for 0.5 seconds. So because we have selected a delay of 0.5 seconds. So very challenging application. Another application is to detect transparent object. Transparent object could be a very wide range of objects. In this case, we use the CFDR F3 fiber with a reflector. Now we have selected, for example, in this case, a RL100D self-adhesive paper, but you can work also with a plastic prismatic reflector. The sensor works correctly in any case. So the first thing is to adjust the sensitivity, pressing the set button. As before, with the keypad, we decrease the energy threshold of 10 points to select very small energy difference. And now we can start to work. The first is a semi-transparent, very irregular TNT object, but we can work also with the net, plastic net used for vegetables, fruits, and so on. But also we can use a very transparent plastic object that is very transparent, and also, as you can see, the position is not very irregular, this position, so you can detect without any problem. The sensor is adjusted to detect only the reflector. As you can see, if we switch from a reflector to a shiny object, the sensor doesn't detect the shiny object as a reflector, so it's detected in a very, so the sensor works in a very regular way. So I pass again the speech to Giovanni to complete the presentation.
Okay. Okay, thank you, Giovanni, for showing us how, let's say, challenging could be the applications where we can use these new products. So now on, we launch this challenge to you to show us how other, let's say, hard and challenging applications you are able to find with these new products. So now we reached the end of this very intensive, let's say, online session, and it's time to summarize the contents that we have learned today. First of all, we have talked about the main technical features of the new FY2 and FY3 amplifiers. Then we have talked about the main characteristics of new plastic optical fiber. Then we have seen practically how to adjust FY series. And at last but not least, we have seen some special applications, the detection of liquid drops and the detection of transparent objects. Obviously, it is not enough to say about these new products. It's the reason why we invite you to write us at info@microdetectors.com, not only for asking us about questions, about doubts, about clarifications, but also to share your observations, your feedback, and why not other new challenging applications that you discover to solve with these new products. Also, we invite you to always be connected with our website, microdetectors.com, and to subscribe to our YouTube channel and follow us on LinkedIn in order to be always updated with our events. Okay, now, let's say, before going to the greetings, I want to call my colleagues Giovanni and Fabrizio. Please show you and don't be shy, because they let's say they collaborated, actively collaborated a lot. Fabrizio is here also. If you are not able now to, I can grant is present and is greeting you. So I send you greetings from Fabrizio. Okay, now we definitely reached the end. So thank you for your time and your precious attention, and see you soon at the next webinar. Bye-bye.